Welcome to a Sim Code. Join our community of learners. Hit like, subscribe, and start coding like a pro. In this video, we will implement a simple queue using arrays in C. Standard I/O library for printing output to the console. Standard library for memory allocation and other functions, not explicitly used here, but useful for advanced operations. Queue size is defined by max, which sets the maximum number of elements the queue can hold. A queue has a fixed capacity and cannot hold more elements than this number. The queue will hold a maximum of 5 elements at any time. We define the queue structure, which is our data container. A queue is a linear data structure that follows the FIFO, first in, first out, principle. Items is an array that holds the actual elements in the queue. It can store up to max elements. Front is the index pointing to the first element in the queue. If the queue is empty, this is -1. Rear is the index pointing to the last element in the queue. If the queue is empty, this is -1. Initialize the queue. This function sets up the queue as empty by assigning -1 to both front and rear. When the queue is empty, the front pointer is set to -1. When the queue is empty, the rear pointer is also set to -1. A queue is often used in systems where elements need to be processed in the same order they arrived. It's called first in, first out, FIFO, because the first element added is the first to be removed. Check if the queue is full. A queue is full when the rear pointer reaches the last index in the array, max 1. If the rear pointer is at the last index, max 1, the queue is full. Return 1 to indicate the queue is full. Return 0 to indicate the queue is not full. A queue can only hold a limited number of elements, so the check for fullness ensures we don't try to add more elements than it can handle. It's important to handle this scenario to avoid memory overflow or errors. Check if the queue is empty. A queue is empty when the front pointer is -1, meaning there are no elements to the queue. If the front pointer is -1, the queue is empty. Return 1 to indicate the queue is empty. Return 0 to indicate the queue is not empty. Before removing an element, we check if the queue has anything to remove. This prevents errors like trying to dequeue from an empty queue. Add an element to the queue and queue operation. This operation adds the element at the rear of the queue. Check if the queue is full before adding a new element. If full, return and stop the operation. If the queue is empty, front equals -1, we set the front pointer to 0. The first element will be at index 0. When the queue is empty, the rear pointer is also set to -1. Move the rear pointer to the next position to add the new element. Store the value at the position of the rear pointer. Output message for the enqueued element. The enqueue operation is how we add elements to the queue. We first check if there is space, not full, then we add the new element to the rear. If the queue is empty, we reset the front pointer to 0. Remove an element from the queue, dequeue operation. This operation removes the element from the front of the queue. Check if the queue is empty before trying to remove an element. Return -1 to indicate that the dequeue operation failed. Queue is empty. Retrieve the value at the front of the queue. If the front equals the rear, it means there was only one element in the queue. Reset the front pointer because the queue is now empty. Reset the rear pointer as well. Move the front pointer to the next element in the queue. Output the dequeued element. Return the dequeued value. Dequeue is the process of removing the front element of the queue. If there is only one element, both the front and rear pointers are reset, indicating an empty queue. Otherwise, only the front pointer is increment. View the front element without removing it. Peak operation. If the queue is empty, return -1 because there is nothing to peek at. Return -1 to indicate failure. Queue is empty. Output the front element. Return the value at the front of the queue. The peek operation lets you look at the front element of the queue without removing it. It's helpful when you need to know what's next in line without modifying the queue. Display all the elements in the queue. This function prints all elements from front to rear. If the queue is empty, there is nothing to display. Return early if the queue is empty. Traverse from the front to the rear and print each element. Print each element in the queue. Print a new line at the end for better formatting. The display function helps visualize the current state of the queue. It shows all the elements from the front to the rear, giving you an understanding of what's in the queue. Main function where we test our queue implementation. Declare a queue variable named queue. Initialize the queue. Test the enqueue function. Add elements to the queue. Add 10 to the queue. Add 20 to the queue. Add 30 to the queue. Add 40 to the queue. Add 50 to the queue. Try to add 60, but the queue should be full. Display the current state of the queue. Print the elements in the queue. Peek at the front element. Should print 10 because it is the first element. Dequeue elements from the front. Remove 10 from the queue. Remove 20 from the queue. Display the queue after dequeuing some elements. Print the remaining elements in the queue. End of the main function. In the main function, we test the queue by adding elements, enqueue, removing elements, dequeue, and checking the state of the queue display. We also use the peek function to view the front element without removing it. Now run our code. Thanks for tuning in. Be sure to like and subscribe to stay updated.